process of calculating the acceleration of the bar of soap. So I could factor g out again to make this a little bit easier. I've got g times sine of 8 degrees minus 0.06 times cosine of 8 degrees. And now I calculate. So I have 9.8 acceleration due to gravity on Earth multiplied by sine. I have to remember how to get to the trig functions on my calculator of 8 degrees minus 0.06 times cosine of 8 degrees. And then I think I have to close all those parentheses for it to work. So I should have an acceleration of 0.78. Let's add an extra sig figure. 1/6, this is in meters per second squared, because g itself is in meters per second squared. Sine of 8 degrees is unitless. Cosine of 8 degrees is unitless, and mu sub k is unitless. So I have a very small acceleration compared to free fall, g of 9.8 meters per second squared. But this is a really barely inclined angle, and I also have kinetic friction. So I went through Newton's second law to find the acceleration of the block, or bar of soap. In order to use Newton's second law, I had to find the into the hill component of pull of gravity and the down the hill component of gravity. And then I used my understanding of kinetic friction to find a term dealing with kinetic friction. I applied Newton's second law, I factored mass out of it, and then I calculated the acceleration. Now, finally, I can go back to September and the middle of October and apply kinematics to solve the problem. So what I wanted to know from the beginning was how much time does it take for this bar of soap to slide down the hill? So I'm going to go ahead and use the position equation because I'm feeling like Friday afternoon, Friday evening, I don't want to use two equations. So position at the bottom of the hill, x, I'm here, is 9 meters. I'm going to drop units because it's not going to fit. X naught, starting position, 0. V naught, starting velocity, is 0. So half times acceleration, 7,816, times time squared. It's solvable, right? So 9 times 2 divided by this acceleration. I probably shouldn't have rounded at all. I should have saved it in my calculator, but I think it's too late. Yeah, divided by acceleration. Now is the time when I'm going to be making some algebra errors. So 23.0296, cha-cha-cha, I'll keep it in my calculator, equals t squared. And so t is equal to plus or minus the square root of that value. Oh, I should have been letting you see this. Anyway, plus or minus 4.7989, I probably should say 4.80, round to 3 sig figs as per usual. Seconds, we choose positive because time doesn't roll backwards as far as we know. So 4.80 seconds. And I'm not worried about that rather long time because it's 9 meters and it's barely inclined. I think that's reasonable. I haven't actually looked at the solutions to know. Number 49. According to our solutions manual, which we know is a little sketchy. Yeah, so the solutions manual number 49 is not problem 49. Because why would I do that? 50 is the solutions manual number 50 is our problem number 49. So we're one off, I guess, on the chapter 4 solution. And the manual says 4.8 seconds. So great, good for us. And that is it for Friday night. The end. Have a lovely weekend.